So in this lesson, we're going to be starting to learn about the Dovetail Theorem, which is a special type of arrangement of triangles that we're going to see in our geometry problems starting from now on. So the Dovetail Theorem has to do with this model right here. And as you can see, it is a triangle ABC, that has been split into 6 parts. So let's see what's so important about this, and let's look at the 3 main relationships that this has. So the area of triangle AGB to the area of triangle AGC, that ratio is the same. That ratio is the same as the area of EGB to EGC. So why is that? So the ratio is the same. So it's not saying that it's exactly the same, but the ratios are the same. Here is why. Because over here, so this is our triangles AGB and AGC, right? They have the same height. It's just that their bases, they have a different length. Over here, BE is not the same as EC, and even it was, this would still hold true. Anyway, these 2 bases have that relationship. So actually, the ratio of AGB to AGC is the same as EGB to EGC, which is the same as EB to EC. And here's why: because in these 2 triangles, they just need 2 lengths, right? Their bases and their heights. Their heights are the same, so it's their bases that really make the difference in their areas. And it's the same for these 2 bottom triangles, EGB and EGC, right? So they share that height. It's their bases or their lengths that's different. So that's what is making their 2 areas different. Again, if it was half-half, the relationship would still hold true, 1 to 1. All right, let's look at our second one here. So it's really just tilted around if you tilt this over. So BGA and BGC, right? So if you tilt it over, you see that their ratio is the same as FGA to FGC, which is the same as FA to FC. Now, why is that? Well, again, because let's first look at this pair, right? Their heights are the same. They share the same height. It's their lengths that could differ. So that's what's also causing the areas to differ. Same with FGA and FGC, right? They both have FG as their height. It's just that their lengths right here, those are different. So that's what's making their areas differ, and their lengths are FA and FC. So basically what you need to know is the ratio of a triangle's length or height. So the ratio of 2 triangles' bases or their heights will affect the ratio of their area. And if both triangles have a different base and a different height, that is also something that is possible. But again, say one triangle's height, right? One triangle's height was 1/3 that of another triangle's height. That would still be possible. The area of this triangle is just 3 times that of this triangle. Okay, now let's look at this third one here. Again, it's just flipping this model around again. So the area of CGA to the area of CGB, that ratio is the same as DGA to DGB, which is the same as DA to DB. So that's the same, right? Because they share that same height, and so their height never changes. but it's their bases, the length of their bases that will change. So that's what's making a difference. Anyway, so thank you for listening to the lesson of this series, the Dovetail Theorem. This is a very important geometric model we will be looking at later in Math Olympiad. So thank you for watching, and see you next time.